Welcome to a technical overview of TLF Systems' ConfD product, presented by our Principal Solutions Architect, Jan Lindblad.
Operators are looking for a network API that will enable them to control the network from a single API. Rather than going directly to individual devices, they want their service applications and device setup to come from a single point and go out to all the devices, making the network look like a federated database. This is what the software-defined networking movement is all about, to give control to the operators from a centralized point, so that you can run advanced, sophisticated applications that don't need to care about how you actually communicate with the devices, and especially don't need to handle all the failure cases that can occur if you get an error on the third device halfway through a script. If you take the traditional service applications and device setup scripts that you have, usually more than half of the code in those is related to error handling. And if you have network-wide transactions, that error handling goes away. If you compare the ConfD product with the traditional solutions for the on-device embedded management systems, there are lots of available options for you when it comes to protocol-focused agents. There is a number of different SNMP agents, there's a couple of different CLI engines, there are a few netconf server implementations that all concentrate and focus on one particular network interface. That gives you a stovepipe solution that is behaving in one way for netconf, in a different way on the CLI, and the third way on SNMP. And it gives you feature lag because you have implemented this sort of functionality. The latest functionality may be in the CLI, but maybe not in SNMP or not in netconf. So then you get what we call a feature lag. Yes, it's coming out in the web UI in the next release. I'm sorry, Mr. Customer. And it's also, these agents are only focusing on the protocol layer. If you contrast it with ConfD, ConfD is an onboard device management framework that takes care of many more aspects of the system than you would do with these protocol stacks. The applications running within the ConfD system, they don't even know which one of the management agents that are that come out of ConfD that are in use at any particular point. The request may be an SNMP request, or it may be a netconf request, or it may be a CLI operator doing something, but the applications within the systems, they don't know that. So since we auto-render the management interfaces from the data models, it's a data model-driven application, we have the same functionality available immediately across all of our management interfaces. So here's a block diagram of ConfD. In the middle, you see the core engine. That's the majority of the functionality inside the product. And I'll talk about what goes on in the core engine in just a couple of minutes. On top and below the ConfD core engine, we have the different APIs. We have the management agent API on top, data provider API a little bit lower down, and the managed object API to the database. On top of the management agent API, we have a number of different management protocols. First, we have netconf. It's a full-blown implementation of all the optional capabilities in netconf. It supports, especially important is the support of network-wide transactions, which makes a ConfD system able to participate in a network-wide transaction coming from a network manager. We have SNMP. That's SNMP version 1, V2C, and V3 in any combination. We have a REST API for popular data center scripting applications, for example. We have 3 different kinds of CLIs, and we have a modern Web 2.0 kind of web UI, Ajax-based, that all come out of the ConfD product. And you can choose which ones of these that you are interested in as a customer. It's also possible to build yet other management interfaces on top of the management API. That is something a customer can do himself, or we can do at TLF. And then we can release these as add-on modules for later releases. And they can just be added to any product that exists in the field today, because the applications running down within the system, they don't really know or care which of these management interfaces a particular request is coming in from. Inside the ConfD core engine, we also have a database called the CDB database. That is where you typically store your configuration. And you can also store other things in there, like alarms, performance data, internal state, whatever you like. The CDB database is actually optional. You can you may choose to use one or more external databases instead of or in combination with CDB if you prefer. Especially in the case where you have a lot of legacy applications already integrated with an existing database, this option may make sense. What we find is, though, that most people choose to use CDB because it has very good properties for an embedded system. Most of the open source and stock databases available out there are made for a server environment where they have certain assumptions about the availability of memory and other characteristics that may not be perfectly suitable in an embedded environment. Whereas CDB is created by the TALF staff. We have had a lot of people here in the company that has written commercial databases in the past. And this is a special purpose database for the embedded environments with good characteristics in there. The first thing you do when you work with the ConfD product is that you create Yang data models. Yang is a data modeling language coming out of IETF, standardized as RFC 6020, that sort of replaces SNMP MIBs as the standard data definition language coming out of IETF. As soon as you have a Yang data model, the Yang data models describe whatever you can configure on the device, everything you can monitor on the device, all the administrative actions that you can execute, like reset the counters or reboot, and the notifications the system can generate. As soon as you have a Yang model that describes these elements for a particular device, we render all the management interfaces automatically. So you get a netconf, SNMP, REST, CLI, and Web UI interface with zero programming. Just have that Yang models in place, and you will get those those interfaces up and running. These Yang models are also excellent documentation of your system, because that's exactly what the operators need to know about your system. What are the possible values you can set? What are the types and ranges of them? What are the limitations? What are the restrictions? If you put this value to 5, what are the restrictions of this other value over here? All of that is described in the Yang model in a formal fashion. So that's a very good documentation of your system. And should you use the NCS product from TALF, which is a network management solution, NCS will immediately be able to manage devices as soon as you hand over the Yang models with zero programming. We are also using the Yang data models for the database schema. So the CDB database is automatically picking up the fields and the structure of the Yang models and put that into database tables. There is no database administration console whatsoever for CDB. It's all automatic. So if you add a new table or a few more columns in someplace in the Yang models, the CDB database will automatically adapt. So here's a block diagram again of ConfD, but this time we open up the ConfD core engine so you can see all the things that go on inside it. On top, we have transaction management. And if I were to characterize what ConfD is in just a few words, I would say ConfD is a transaction manager. At the heart and soul of what ConfD is, it's dealing with transactions in every possible way. And part of the reason for that is, okay, with netconf, the reasons why netconf was invented was to support important operator use cases like network-wide transactions. Transactions coming out of an NMS or OSS system that goes to many devices. And when you provision a service across a network, you want all the devices to either accept this configuration change or activation, provisioning operation, or if there's a problem anywhere, don't do anything to your network. So network-wide transactions is at the core of netconf, and of course something that ConfD supports. And because of that, it needs a lot of transaction management in order to be able to participate in these network-wide transactions. But there's even more transaction management going inside the ConfD core engine. You can see the CDB database being here, but you can also see on the bottom you have the external databases. You can plug in 0 or more of those. And you have the ConfD gateways, where you can plug in other ConfD systems acting as sub-agents to this ConfD system, all with their own set of databases. So potentially we can have a fairly large collection of databases. So what ConfD does, it does database federation, so that you can make many small databases look like one large database. So it's even more transaction management going on inside ConfD because of this. Next, we have session management and authentication. Whenever an operator is logging into ConfD through any of the management interfaces, he will be subjected to an authentication mechanism that is the same for all of the management interfaces. He will have to supply either username, password, or username and a cryptographic token of some sort. And this is then verified to be a particular user or particular role in the system by looking up either in the built-in CDB database or looking up from the user list in Linux that's running through PAM, or in an external server like over Radius, TACAX, and so on. You can also mix and match these. So usually we see a combination of looking up in the internal database for some emergency users and then going out to a Radius server to actually look for the real list of users, and so on. As an operator logging in has been authenticated, he is assigned one or more roles in the systems. And these roles, they decide what the operator will be able to see and not see, what he can change and not change, what he can execute and not execute. And this is decided by rules that are much like firewall rules, that can be very coarse-grained, saying for this entire routing subsystem you can do anything you like, but for this particular password field over here, you cannot see that. And this affects the way that the management interfaces are rendered, so that fields that you are not allowed to see are just not in the system. They appear as not being there. Next, we have redundancy and replication. So ConfD can play in a high availability environment. ConfD itself does not implement a high availability framework, but it's designed to plug into a high availability framework, if you have one. So you can assign one ConfD instance the role of being an active node, and another ConfD system the role of being a passive node or standby node. And then the management system will tell ConfD that you shall be active, you shall be standby, go replicate this master instance over here. So the configuration data in one instance will then be replicated to 0 or more standby nodes. Then we get into event logging and audit trails. So redundancy replication obviously gives a lot of events back to the high availability framework if you have one, which is things like, okay, I just got a connection from a standby node, or I lost connection with my standby node, or I'm now in sync with my master, and so on. So all of these events are interesting information for the high availability system. Other events that applications may be interested in is, for example, operators logging in or logging out, or making configuration changes, or possibly including all of the gory details of what the particular transaction change was. And you can use this to build up very detailed audit trails. For example, which operators tried to execute what commands but got access denied, or which commands that were actually executed, or both of those, and so on. Next, we have validation. It's obviously very important that whatever configuration an operator inserts into a system has to be consistent. So there's a lot of validation going on in ConfD in order to offload applications from doing validation work. So first, we have syntactic validation. If you in your Yang model write that this particular field over here is an integer with a particular range, say 1 through 99 or 1300 through 1999, or the word disabled, then that's something that ConfD will validate automatically. The applications will only get the proper values and do not need to check that. But that's the basic syntactic validation. But that's a lot of tedious code that can be removed by that. Then we have semantic validation, which is more interesting. It's about how a particular value is valid in combination with other values. For example, one of the common semantic constraints is uniqueness. If you have a particular table, you may have the third column being an IP address or something like that. And you may want that no two rows in this table can have the same IP address. So then in the Yang model, you just declare this third column to be unique. And then ConfD will validate that the operator is not entering the same value more than once in the third column. Or maybe it's not the third column, it's maybe the combination of the third and the fourth column, which is IP address port number. So you can have the same IP address, you can have the same port number, but not the combination of those two. And then just declare the combination of those two to be unique in the Yang model, and ConfD will validate that automatically. Or another popular semantic constraint is a reference. Let's say you have a routing subsystem that has a reference into the interface table. So you have to name one of the interfaces that it's supposed to run on. You just declare it in the data model to be a reference, and ConfD will take care to validate that indeed a particular interface by that name exists. And if it does not exist because it's been deleted or never existed or it was renamed or whatever happened, ConfD will stop the transaction and say, hey, stop, you can't commit this is inconsistent, you have to go fix this first. And the operator can then create an interface by that name or rename another interface to that name, or simply remove this routing subsystem reference that references this interface. Whatever it is, ConfD will only accept the semantically valid configurations. And another type of semantic constraint that is very common is that you have dependencies between the values. For example, this value over here must be less than this value over here. Or the sum of all the numbers in the third column has got to be less than the number over here. Just declare it in the data model, and ConfD will validate that automatically. No code is required in the applications to do that. So this is happening automatically in ConfD, and the applications do not need to be involved. But it is also possible to actually have a call out into a particular application if the application wants to participate in the validation of some data item. For example, maybe if you have a password field, maybe you would like to do a dictionary check, and the dictionary check is too complicated to do in a Yang semantics. You have to do that in code in your system. Or maybe your application would like to participate in the transaction in order to reserve resources or something like that. So that is also possible through the validation stage. Next, we have rollback management. So every time an operator is making a configuration change, we are saving an undo information file called a rollback file so that we can undo that particular transaction and get back to our earlier configuration. Since we do this for every transaction that the operator commits, we get a sort of timeline backwards, a time machine if you like, so we can go back to any prior configuration that you ever had. So let's say, to give you an example around this, let's say I'm an operator, I get into the office in the morning and I want to do a big network change. So I sit down, 8 o'clock, typing and hitting commands and doing stuff, but then somebody calls me, I need to go away to fix a problem someplace. So, but I don't want to leave the network in this half-configured state, so then I do a rollback to 7:50 this morning, undoing all the changes I made. And the system is back to a stable state, and I can go to my to help my customer. Then when I get back, I want to continue where I left off. So then do I roll back to 11:50, which is just before I left. And then I can continue working from that point on again. So that's what rollbacks give you. Then we have upgrades and downgrades. So most of our customers, they design the system, they test it, ship it, the customer installs it in the network, they configure it up, and leave it in the network for, say, 15 years or something like that. After 15 years, they will power it off and throw it in the scrap. But in those 15 years, there will be a lot of software updates coming from you, I'm sure. Software updates often include new functionality. New functionality means new configuration items. New configuration items means a new database schema. So when the customer installs this software upgrade with the new database schema, he already has configuration for this device in his network. And the one thing that he cares most about is to keep that configuration. If you fry the device and it goes up in flames, you can always replace it. Just put another one in, and that's fine. But if you lose the config, that's a problem. So you have to be able to insert this new software into the running system, keep the old configuration running there, upgrade it to the new schema in runtime. And that is something that ConfD can do as well. Either fully automatically or with some help of applications if you do more tricky things. And the same system works for downgrades as well. So we don't really care if it's an upgrade or downgrade, just a schema change. Here is a deployment diagram of a typical deployment of ConfD. ConfD can be deployed in many different ways, but it's very common to have a central ConfD running on one blade, for example, and then some applications running locally, and some other applications running remotely. The applications, they link with our access library, and the access library is then communicating with ConfD over sockets. And from ConfD's perspective, we don't know or care whether those applications are running locally or remotely. ConfD is handling all the marshalling and that is required, even if they are running on different CPU architectures and things like that. And the central ConfD is then providing the management interfaces, and the operator will not know or feel any difference whether applications are running locally or remotely. You can, of course, deploy ConfD in many other ways with high availability support or sub-agents and other things too. So what does ConfD provide for you? It's providing a few things to make your customers happy, because it makes your device manageable. You can program to it. It becomes a part of your network API, and it complies to all the standards in this space. It really fulfills the SDN promise. So if you want your network to be programmable, this is an excellent idea. It provides a web interface, 3 different command line interfaces, REST, SNMP, and netconf programming interfaces. It's a fully transactional system with full rollback support. It supports proper validation on the Yang level as well as on the application level. It's focusing on configuration and monitoring aspects. And it has no feature lag because you have the same model that renders all the management interfaces automatically for you. So you get the same functionality across all the interfaces. It also saves you time when you're developing. Since the management interfaces are rendered, you don't have to program them, and that's a huge time saver. Also, being Yang model driven means that the EMS and MS team can start working immediately as you have those Yang models. They don't have to wait for your system, your device to be ready and implemented. And you can, since you get a fully functional interface up immediately, you can get a basic interface in there quickly and then iterate and refine over time. But you have something that is working. You can touch everything that you have in your model immediately, and then you can add more functionality around that as you go. ConfD is a platform. It has a lot of core components. It has a built-in database that you can use if you like. It has very rich APIs, and it has been used in the field for many years and by many of the major operators in the networks for many years already. So it's a well-proven solution. And that's how it works.